Hello everyone. This video is on two-dimensional random variable part 3, and this will be concentrating on the random variable x and y are going to be independent or not in discrete case. We will see that the given problem is going to be a condition 1 where your x and y varies as x taking the value 214, y taking the value 135 with the probabilities given. We have been asked to examine if x and y are going to be independent. The case is that we have a joint probability mass function for a discrete two-dimensional random variable. What is going to be the condition for independence? We know that x and y are going to be independent if Pij equal to Pi dot product P dot j. What is Pi dot? Pi dot is going to be the marginal for my x and P dot j is going to be my marginal of my y. Now we will compute the marginal of x and y. How to compute the marginal of x? Now x marginal is got by adding it. X equal to 2 is fixed, which is going to vary. The variation is taken along your y. So what you do is the variation along the y is going to be estimated, and we find that the total value of adding 0.1 plus 0.2 plus 0.1 is going to be equal to 4 over here. The next one is going to be x equal to 2 is fixed, which is varying, y is varying 0.15 plus 0.3 plus 0.15. So the total value is going to be equal to 6 here. Now the probability marginal values for your y. How to get the marginal values for y? The marginal values of y are got by keeping your y fixed and varying your x. The variation of x is happening in this way. So you have 0.1 plus 0.15 to be 0.25. X equal to 3 is fixed. Y equal to 3 is fixed, x is varying as 2 and 4, so 0.2 plus 0.3, it is going to be 0.5. The next value, y equal to 5 is fixed, x is varying as 2 and 4, so when you add it along the row, you have it as 0.1 plus 0.15, so 0.25. So we have now estimated what is going to be the marginal values for my x and marginal values for my y. So these conditions where my y varies, what are this y variation called as marginal probability function of y. So you have this as P dot j. And what are these two quantities? These are nothing but my marginal probability function of which random variable? The random variable x. So how they are denoted by? They are denoted by Pi dot. Now what is the condition? Pi dot. When I multiply with P dot j, you must be getting your Pij. Now we will take the first one. What is going to be this quantity? This quantity is nothing but my P, which is varying, your x is varying, and which is fixed? 1 is fixed. Now let me multiply this with my x. What is the variation over here? This quantity. What is this now? This is nothing but we have x equal to 2 fixed, which is varying, y is varying. So P2 dot into P dot 1. What must this be equal to? This must be equal to P2 1. Now let us go and check if that is equal to P2 1. What is the value we have at P? X equal to 2, y equal to 1. We have it to be equal to 0.1. So we will have to check if 0.1 will be equal to P2 dot. What is P2 dot? P2 dot is going to be 0.4. So 0.4 multiplied by P dot 1, which is going to be P dot 1, 0.5. 0.25. Now what is 0.25 into 0.4? Yes, this is going to be 0.1. It is going to be true. Let us go and check for the remaining cases. What is going to be the remaining case? 0.15 multiply with the corresponding value of the x and y. What is going to be this? When I multiply 0.25 with my 0.25, which is going to be over here, with my 0.6, what will happen? 0.25 into 0.6. This is going to give me This is going to give me 0.15. So this is also right. Okay, let me take the next element. So match it with the row, match it with the column. So what is going to be the row total? Row total is going to be 0.4 into what is going to be the column value? It is going to be 0.5. What is 0.4 into 0.5? It has to be 0.2. Is it 0.2? Yes, it is 0.2. Move on to the next element. How to go about it? Row total and the column total. What is going to be the row sum? 0.6, and what is going to be the column sum? 0.5. 6 5s are, this is going to be 0.3. Is it right? Yes, this value is over here is right. Next, move on to the last value. It is going to be equal to 0.4 multiplied by 0.25. What is this equal to? 0.1. Do we have a 0.1 here? Yes, we have a 0.1 here. So the last value 0.15 multiply with the corresponding row and the corresponding column. So 0.6 into 0.25. So this must be equal to 0.15. Is it right? Yes, we have it to be equal to right. So we see that for all the values of x over here, when we multiply with the y over here, we are getting the element Pij over here. So for all the values of I and j, the value is going to be true. So for all the values of I and j, we have the condition Pij equal to Pi dot product P dot j to be true. If this is going to be so, then what do you call this value of P, x and y as? So we call this x and y as independent random variable. So we conclude from the given condition and checking that x and y are going to be independent random variable.